Good day to everyone. Today we're going to discuss part 7 of Module 4 for the subject CE3151. So in this discussion or lecture, we'll be discussing the iteration methods of Gauss Seidel and hakabi. So the iterative methods or iteration methods are seldom used for solving linear systems for small dimensions. This would usually be used for very large systems of equations. So this is more applicable for larger system with high percentage of zero entries. So meaning if our elements in our matrix have several zero values, then the iteration methods will be more applicable. Next, this is efficient, or these methods are efficient in terms of computer storage and computations, and are applicable for any n by n linear system that will follow the form Ex is equal to B. For iterations would have initial approximations or guesses at x equal to 0. So the solution for x would generate now a sequence of vectors with xk until your initial approximation of k, which is usually 0, until your maximum iterations. So if x now is assumed as 0, or we start at 0, that will now be your first iteration. So to understand our iterative methods, let us start off first with hakabi method. So the hakabi method is an iterative algorithm that is used to determine solutions of linear systems that would follow a strict diagonal system of linear equations, meaning we have to check that the diagonal elements of our equations or of our systems will not have any zero component or element. So this is applied for a square system of n linear equations that would follow the form Ex equal to B. So for hakabi method, we now follow two assumptions. The first one is that it follows our general form Ax equal to B, and it will have a unique solution. And lastly, the coefficient matrix A will have no zeros on its main diagonal. So for the procedure for hakabi method, first is to solve the first equation for the value of the first unknown, the second equation for the second unknown, the third equation for the third unknown, and so on. This is now to obtain a derived equation or a rewritten equation. Next step, once you have rewritten your equations, we now make an initial guess for the solution for x raised to o for all unknown values of x. That is, we now compute for the value of x using the value of 0. In here, we'll now be substituting the values of our approximation or our iteration into the right side of our derived or our new equation or the rewritten equation to obtain our first approximation 1. And then we now apply the first or the second method or repeat the second method in order to arrive for our second approximation. So we read steps 2 and 3 until we arrive at two successive approximations which are identical, meaning we have solved already for two iterations giving us the same values for all of our unknowns. And take note that this should be around 3 significant digits or more to be more precise. So to understand the copy method, let's solve an example. So for the given linear system, we are to solve for the solution of the given equations. For x plus y plus z is equal to 7. 3x plus 4z is equal to 11. X minus 7y plus 2z is equal to -2. We will check the given equations would follow now the form Ax is equal to b. In matrix form, we write the given equations as 4, 1, 1, 7, 3, 0, 4, 11, 1, negative 7, 2, negative 2. So as we have mentioned, for the hakabi method, the hakabi method now, this is strictly following that the diagonals should not have a 0 element. So in that case, we now swap row 1 and row 2 and row 3. So we'll now have a new form, matrix form, and from the new matrix form, we can now write our rewritten solution or our derived equations. So we now solve for the first equation, the first variable, x. So we have now x is equal to 7 minus y minus z divided by 4. And then, for the second equation, since nag-swap tayo, this will now compute for the y. So y now is equal to positive 2 plus x plus 2z all over 7. Okay? So transposition lang to ha. So galing yung equations natin, rewritten equations came from here. We just wrote it in matrix form to check if the diagonals are non-zero. Okay? So last equation, we now solve for z. So z, that will now be equivalent to 7 minus 3x all over 4. So this will be our working equations for our iterations. It's for step 1. So you derive or rewrite your equations for the unknown value. So for the first equation, we'll solve the first variable. The second equation will solve the second variable. And the third equation will now solve the third unknown. From there, we move on to step 2. We now apply our initial guess. X is equal to 0, y is also 0, and z is equal to 0. So we substitute our initial guesses in our derived equations. So for x, that is now equal to 7 minus 0 minus 0 divided by 4. And then we have for y, that is now equal to 2 plus our assumption 0, 0 divided by 7. And for z, 11 minus 3 times our assumption 0 all over 4. So simplifying now, our x, y, z is equal to 7 over 4, or that's 1.75. Y is equal to 2.7, or that is equal to 0.286, and then z is 11 over 4, and that is equal to 2.75. So this one now is our first iteration, or this will be under KO. Okay? So after our first iteration, we need two consecutive values or two consecutive iterations that would give the same values of x, y, and z. So we now apply step 3, repeating now the second step until we achieve two consecutive iterations that would have the same value. So for our next iterations, we could now apply this or show it in tabular form to make it easier for us to solve and mas magandang tignan yung ating solution. Okay? So again, we have here our working equations for our variables x, y, and z. We have on the first column our solved values of x, y, and z for the first iteration at x, y, z equal to 0. So for our second iteration, what we will do is to apply now the value of x, y, and z in our working equations. So that will now be for x, that is equal to 7 times y, 0.286, minus z, 2750 all over x. And that will be equivalent to 0.991. And then for y, that will now be 2 plus computed x plus computed z times 2, and it will give us 1.321. And then for z, apply now computed x. So 11 minus 3 times 1.75 divided by 4 will give us a value of 1.43. So hindi pa rin siya pareho. So we now move to the third iteration. So for the third iteration, ang gagamitin ko ng values will be the value computed in our previous iteration. So 7 minus 1.321 minus 1.438. So it will now be 1.06. Then we have y is equal to 2 plus x plus 2 times z. So that's equal to 0.838. Then for z, that is equal to 11 minus 3 times the computed x divided by 4. That's equal to 2.007. Hindi pa rin pareho, so we move until the next iteration. Same process. Substitute ko lang yung values nung previous iterations doon sa ating working equations until we arrive at the two consecutive iterations with the same value. So for the fourth iteration, it will give us for x 1.039, y 1.011, z is 1.955. So hindi pa rin pareho, so we move to the fifth iteration. So for iteration 5, it will give us for x, if we substitute the values in iteration 4, will give us 1.009, y 0.993, z 1.971. Still not the same, we move to iteration 6 using values of iteration 5. 1.009, 0.993, 1.993. Uy, pareho si 5 and 6 for x, y for 5 and 6 are also the same. Pwede nang mag-stop? Hindi pa, since z are not the same. So we move again to iteration 7. So using iteration 6 for x, y, and z, x now is 1.003, y 0.999, z 1.993. Nagpareho na si 6 and 7 for z, pero si x and y for 6 and 7 nag-iba. So again, we continue with iteration 8. So we use the values of iteration 7, substitute this in our working equations. So for 8, we'll have x is equal to 1.002, y is equal to 0.998, z is equal to 1.998. So, hindi na magkapareho, we move to the next iteration, 9. Using the previous iterations, x now is equal to 1.001, 1, 1.999. So, hindi pa rin same. So, we move to the next iteration. So, for iteration 10, we use x, y, z values from 9 in our working equation. So, it will now give us x is 1.000, y is 1.00, z is 1.999. So, yung x na lang. So, more iterations, 11. So, x is 1, y is 1, z is 1.999. Pero pag tinuloy pa natin to, 1.999 can be rounded off to 2. So, our answer now for the values of x, y, and z, the solution of the linear system is x is equal to 1, y is equal to 1, and z is equal to 2. Okay, so that is for hakabi method. So the next method is the Gauss-Seidel method, or also known as the successive displacement. So this is an improved form of the hakabi method, and our first assumption would also start with values at 0. So the difference between the hakabi and the Gauss-Seidel would be that for hakabi, in our iterations, in our next iterations, it will now be using the values that we have obtained from the previous iteration. While for Gauss-Seidel, it will now apply the latest updated values of our unknowns during the iterative procedure. Okay? So again, so almost the same lang yung process for hakabi and Gauss-Seidel. The only difference is that for hakabi, again, we use the values from the previous iteration, while for Gauss-Seidel, we use agad the values that we have computed in our iterations. So we'll understand this better in our example in the next slides. So for Gauss-Seidel method, the second unknown would be determined from the first unknown in your current iteration, and the third unknown will be determined from the first and second iteration. And then, for the next iteration of the first, yung sumunod na dalawa, or yung sinusundan yung dalawa ulit yung gagamitin natin for the iteration. So that's the process for Gauss-Seidel. So take note that the resulting values from the first steps for hakabi and Gauss-Seidel would be identical, but we will now be able to see a subtle difference between the two methods. Okay? So to understand the process for Gauss-Seidel method, so again, we solve the linear system or the solution of the linear system for the given equation. So this is the same as the given equations in hakabi. So tignan lang natin yung difference in the process and the outcomes. Okay? So again, matrix form, check that our diagonal will have no zero elements like kanina. So we interchange now our second and third column so that for our solution, we'll have now the first equation solving for x. The second equation, the new second equation will now be solving for the second variable y. And the last equation will now be solving for your third variable z. So again, this is our working equation. So it's just the same as for hakabi. Step 2, we have our initial guess. X is equal to 0, y is 0, and z is 0. So for our first iteration, we use our first assumption. So x now is equal to 7 minus 0 divided by 4, giving us a value of 1.75, which is the same as our first iteration in hakabi method. So next, we solve for y, which is given by the equation 2 plus x plus 2z divided by 7. So dito, we'll now be using our first assumption and the computed value of x from our first iteration. Okay? So y now is equal to 2 plus 1.75, which is the x na na-compute na in our iteration, plus 2 times our first assumption, so divided by 7. So y now is equal to 0.536. And then for our third equation, that is z equal to 11 minus 3x divided by 4. So sa z, we'll now be using the previously computed values of x and y. So since wala namang y doon sa ating equation. So, x lang. So, medyo madali lang yung example na to. Pero pag merong y dito sa z equation ninyo, you have to use the previous value of y here. Okay? So again, sa Gauss Seidel, dinediretso na natin i-substitute yung mga nasosolve nating values ng unknowns. So with this, z now is equivalent to 1.43. So the values of x, y, and z is our first iteration. So we have here, so again, we could tabulate our answer. So we have here our working equation for x, y, and z, your unknowns. So our first iteration, we were able to get 1.750 for x, 0.536 for y, 1.438 for z. So for our second iteration, so we'll now be using the value of for x. So I'll be using the computed values of y and z here. So we'll have x is equal to 1.257. And then next, for y, ang gagamitin ko will be yung na-compute ko na bagong x tapos yung sa kaninang z. Kasi wala pa naman tayong. So ito yung parang pinaka-latest na value ng z na na-compute ninyo. So y now is equal to 0.876. And then for z, we'll now be using the latest computed value of x. So kung may y dito sa equation, gagamitin ko yung latest value ng y. Okay? So yung latest value ang sinasubstitute natin. Hindi kagaya dun sa hakabi na you compute first all x, y, and z before you move to the second iteration. So dito sa mga iterations natin, we use the latest computed value. So for z, that is now equal to 1.807. Okay? So we now move to our third iteration. So third iteration, that will now be 7 minus latest y is 0.876, latest z is 1.807. So we get now x equal to 1.07. So for y, we use the equation 2 plus x plus 2z. So ang gagamitin natin dito is latest x. So that is 1.079, latest y 1.807. It will give us y value of 0.956. And then for z, latest value of x is 1.079. So z now is equal to 1.941. So for next iteration, we have fourth iteration. So x, we use our latest yz. So that will now be equivalent to 1.026. Next, we have your y. So we use our latest x and z for the y. That will give us 0.987. And for z, we use the latest value of the x. So we get a value of 1.91. So hindi pa rin magkakapareho. So we move to our fifth iteration. So for x, we're going to use this value and this value to get now a value of 1.00. Then for y, the latest x and z will give us 0.996. Then for z, latest value of x and y, and that will be 1.994 for z. So, hindi pa rin magkapareho. So we move to our next iteration 6. So for x, that will now be latest yz. So we have 7 minus 0.996 minus 1.994 divided by 4, giving us 1.003. Then for y, latest x and z. So that's 2 plus 1.003 plus 2 times 1.994 all over 7. giving us a value of 0.999. And then for z, latest value of x, it's 11 minus 3 times 1.003 is all over 4 is 1.998. So again, we do not have consecutive identical computations or results. So we move to our next iteration, 7th iteration. So we have now x is equal to 0.999 and 1.99 divided by 4. X is equal to 1.001. Then for y, it's now 2 plus 1.001 plus 2 times 1.998 all over 7, giving us 1. And then for z, that will now be 11 minus 3 times 1.001 over 4. And we have 1.999. So still no identical values, so we move to our next iteration. So we have our 8th iteration. So x is equal to 7 minus our previous y and previous z, or latest z and y. So x is equal to 1. For our y, latest x and z, it's 1 and 1.99. So the new y now will be 1.00. Then for z, the latest x, which is 1, will give us z equal to 2. So still not the same or identical values, so we move to our 9th iteration. So x now will use the latest y and z. So 7 minus 1 minus 2 all over 4 will give us 1. And then for y, the latest value of x and the latest value of z. So 2 plus 1 plus 2 times 2 all over 7 will give us 1. And then for z, 11 minus 3 times the latest value of x, which is 1, will give us 2. So 8th and 9 iterations are already identical. So we stop already at the 9th iteration. So our solution now will be for x is 1, y is 1, and z is 2. So if you compare now our result from the Gauss-Seidel, it is the same with our results with the hakabi iterations. So take note, for hakabi, nasa 10 or 11 tayo na iterations depending on the number of decimal places we're going to consider. And then for the Gauss-Seidel, it was reduced to 9. So mas kumonte yung iterations natin. So basically, mas maganda nang gamitin si Gauss-Seidel when it comes to iterations since our iterations will be lesser but more more accurate. Okay? So that's it for the iterative methods for linear equations. So thank you for listening.